In section 2.3, we're going to have an introduction to functions, and in this first video, we're going to go over a couple definitions and a couple example problems. Our first definition is relation, which is a set of ordered pairs. Now we have 2, 3, that's an ordered pair, 4, 6 is an ordered pair, 6, 9 is an ordered pair, and 3, 5 is an ordered pair, and we have a set of 4 of them, which is a relation. Now later, we're going to figure out whether or not it's a function or not. That's represented by the relation. Our next definition is function, which is a relationship between two variables such that each value of the first variable is paired with exactly one value of the second variable. We'll look at a couple examples of this to clarify what that actually means here in just a second. A function may be represented by data in a table. It could be an equation. And it could be just a set of ordered pairs. A relation could be a function. So there's lots of different cases. So the first thing we're going to do is we're going to see if a table of data represents a function. Now, a table of data is essentially a bunch of ordered pairs. You have 2, 1 is an ordered pair, 3, 2 is an ordered pair, 2, 3 is an ordered pair, 3, 4, and 2, 5. Now, the way we tell if this is a function is whether or not our x's repeat. If they repeat, then you don't have exactly one value paired with the other. You have, well, in this case, 2 is paired with 1, 2 is paired with 3, and 2 is paired with 5. So the x's repeat, well, 2, 2, 2, and also the 3's repeat. So this is not a function. Doesn't matter if it only repeats once, as long as you have one repeating x, it's not a function. Let's look at the second one. Feel free to pause it and try it on your own if you have an idea. Well, here I have -2, -1, 0, 1, and 2. Do any of the x's repeat? They do not. So, yes, it is a function in this case. The main part to remember, ask yourself, do the x's repeat? If the x's repeat, not a function. If the x's don't repeat, then it is a function. Our next two definitions are going to be domain and range, which go together a lot. Domain is the set of all possible values for the first variable, which is x usually, and the range is the set of all possible values for the second variable, which is usually y. Not always x and y, but usually that's what we're going to come across in this class. So first off, let's take a look at our x values. We have 1, 2, 3, 4, and 5. So my domain will be 1, 2, 3, 4, and 5. I'm basically just writing down all of my x values. When we're dealing with a graph, it'll look a little bit different, like an equation of a line. That'll be a little bit different with domain and range. But when we're dealing with ordered pairs like this, a table like this, it's just writing down my x values. So for my range, I have 2 and 3. And then it repeats 2, and then 3, and then 2. So I really only need to write down the number once. So there we have it, domain and range, when we have a table of values. In this first example, we're going to state the domain and range of the relation, and then we're going to state whether it is a function or not. So let's focus on the first part, domain. Remember, our domain, those are the x's. The range, that's our y's. Let's write it in numerical order as well. So we're just going to write down our x values. That's all we have to do for domain. So we start with our least and go up to our greatest. -7 is the smallest number. Then we have 4, 8, and 16. Excellent. And then our range, our y values. Well, let's see here. We have 5, and then we have 8 over here. Then we have 12 and 23. When you're dealing with a lot of numbers, it can help to cross them off as you go. So 5, then 8, then 12, then 23. Make sure that you got them all. All right, so we have our domain and our range. Next thing, is the relation a function? Well, we have to think back. What does it mean to be a function? Our x's cannot repeat, so we have to remember that. If the x's repeat, it's not a function. If the x's don't repeat, then it's a function. Well, here I have 7. Do I see any other, sorry, -7. Do I see any other -7s? Nope. Here I have 4. Do I have any other 4s? Nope. Here I have 8. Do I have any other x8s? Nope. Do I have any other x's that are 16s? Nope. So I do not see any of the x's repeating, which means that it is a function. There we go. And we're done. Make sure you're always reading the directions that you answered each part. we got the domain, we got the range, and we stated whether or not it was a function. So we did all three parts.